Hello, everyone, and welcome to today's webinar. You are going to be learning a whole lot of cool things today, and this is going to be a great collaboration between Fusion 360 at Autodesk as well as Zometry. We have a big agenda. You just saw Greg's video turn on. He's our co-host for today, and we have a packed agenda. So let me actually go and share that agenda with all of you. There we are. We're going to start off with some intros. Then we're going to talk about what is Zometry and how can they help your product development for about 5 to 7 minutes. We're going to have an example project designed in Fusion 360 and then prototyped via Zometry. That'll be about 30 to 35 minutes. And then lastly, we're going to have some time for Q&A. So I'll start on the intro side. My name is Jason Lichtman, and I'm a Senior Technical Specialist for Design and Manufacturing at Autodesk. I help our customers learn how Fusion 360 can help improve their workflows, whether they already have Fusion 360 or they're using another Autodesk product like Inventor, or they're starting from another CAD platform entirely. I am a mechanical engineer by background, and I spent a little over a decade in industry designing consumer products. So taking ideas, turning them into 3D models I could visualize on the screen, into prototypes I could hold in my hands, and eventually into mass production. I am joined today by Greg Paulson, Director of Application Engineering at Zometry. Greg leads the application engineering team at Zometry, working directly with customers on special case projects. He's an expert in all things manufacturing. I've seen this firsthand, from 3D printing to CNC machining, all the way to injection molding and beyond. He spends a lot of his time helping Zometry customers design for manufacturing and get the most out of their projects. Greg, welcome.
Super happy to be here. Thanks, Jason.
So we have a packed agenda. I think we should get to the really fun stuff. Are you ready to talk about Zometry and what Zometry is able to do?
Yeah, absolutely. I'm very excited about this webinar because it's practical. It's something where we're all facing, especially if you're in a design phase, where you're usually designing on purpose, right? You know, you're usually designing with the intent of making stuff. And I think what you're going to show on Fusion 360 and what we do at Zometry, helps everything go from that digital model to tangible reality. So I'm going to drive into Zometry and tell you a little bit about it while I'm touring the site here. And let me just hijack the screen.
Please do.
All right, so you should see custom manufacturing at your fingertips. Is that right?
I do.
Awesome. So yeah, Zometry, we make parts. All right, my demo's over, guys. No, but we make parts, and we've invented a process that solves this problem that you may have with procuring manufactured goods. Typically, if you're looking to get a CNC machine part or a 3D print made, you're going to that specific CNC vendor or the 3D printing vendor or those vendors and kind of shooting out an email and starting that discussion. And sometimes it may take days to get responses back, and sometimes those responses are not, what you're looking for. Sometimes it's say, when do I need it by, or another question, when really you're just looking to get something made. On the other side of that too, these vendors are running into that exact same issue where they may be, a CNC machinist, and they're working with a local to local customer base. And they may be the perfect machinist to do a job that you're looking for, but you just may not even know they're out there, and they may not know you're out there because they just don't have that reach. So Zometry actually has created this manufacturing marketplace, essentially, that consolidates both buyers and suppliers in one place. It allows us to offer over a dozen different manufacturing technologies right on this site. And even better is that it instantly prices them. So not only are we connecting you, but we're also providing instant quoting for things like CNC machining, 3D printing. We actually have 7 3D printing manufacturing technologies that instantly quote on our website. We have injection molding services. We do sheet metal fabrication. We have urethane casting, and even more services that we're adding all the time because we're powered by this connection. So we're basically leveraging 3,500 US-based manufacturers, as well as 4,500 across the globe. So just a massive manufacturing supply chain where you're going to have total access just by clicking the button, get a quote up here. And so it's, one click and an entire global network at your disposal. So I want to show really quick while we're on this website, I want to show you a little bit of the tools that we have while you're in that design phase. And then I'll go through a quote demo. And I know, Jason, we're going to be designing some parts in real time as well and doing some modifications and going through some more quotes there. So I'm going to give you kind of the elevator pitch on that. So just real quick, when I'm designing, I have skill sets. I'm lucky enough to be experienced in many of these processes because of the nature of my job, but you may be working mostly in like a sheet metal world or a CNC machining world or 3D printing world. And you may need to dive out of that sometimes, but maybe you don't know how to design for that particular process or what to look out for. I really recommend Zometry has a lot of design tools and guides and even like videos to help learn about materials under our resources tab. And I always want to point this out because it is just such a useful place to go as you're learning. So I'm going to be clicking on the design guides real quick here. If my guys, we're doing this live here, so let me refresh here. I've only had this tab open for about the last hour, so go through, boom, boom. Jason, this is the power of a live demo. Okay, there we go. It refreshed.
It happens. That's all good.
Yeah.
Now, those design guides that you talked about, the whole idea here, I think you were telling me, is that someone might be an expert in one particular design manufacturing process, but not necessarily in all of them. So if I, for example, I have a background in injection molding, I might not need a design guide for injection molding, but if I get a customer that's asking me to design a part for sheet metal, I should read that sheet metal design guide, shouldn't I?
Yeah, absolutely. And I actually talk about sheet metal in particular. One does not accidentally design a sheet metal part. Like it's one of the most intentional fabrication processes out there. But you may not know too much about bend radii or tolerancing, because tolerancing is really interesting in sheet metal because there's different classifications. There's a feature to feature on the flat pattern tolerance. That is going to be like if I have 2 holes because I'm going to be laser cutting, and that's actually a laser cutter's tolerance. There's the thickness tolerance, which is actually the raw material stock tolerance of that, and then a bend feature tolerance, because bends themselves, they're a little tricky, and there's always a little bit of variability there. So just kind of understanding where and how to expect different tolerances and designs is really big, and also helps you better understand how to actually make a drawing for sheet metal parts as well. But as you said, and I apologize for that delay on my internet there, that's not Zometry, that's just my computer apparently. But we do have a design guide for every process that we have, including our 3D printing processes and our traditional processes.
And can I add one more thing there? So one of the things I found when I was in industry is we used to design for injection molding, but then we would 3D print in advance just to make sure that everything is going to fit together. These days, we live in a world where you could actually 3D print your end-use parts, your production parts. And so I think it's important to know that these design guides are not just there to help you design, let's say, a sheet metal part, but if you're going to design a 3D printed part to be the production part, you might want to change your design slightly to accommodate that manufacturing process. This is a great resource to be able to learn how to do that.
Yeah, and absolutely. We have even some 3D printing processes that are specifically catered to production, serialized production. Carbon DLS, which is kind of like stereolithography, but it has a secondary cure that creates essentially urethane parts out of the 3D printing process, is a really good process when you're looking for more of an end-use serialized production need, because the materials have better longevity, better properties with the surface finish that you would typically expect with like a smooth SLA print. But if you have questions about that, again, like design guides are great. And then also, of course, we have the resources at Zometry. But let me get to the quote demo here to show a little bit about like what my experience is. So you've designed your parts, let's get a quote. This is the dashboard, so I'm already logged in here. You can see that we actually can instant quote from a variety of base files. So if you do have this a step file, that's kind of like, I consider that the PDF of the 3D engineered CAD world, where step files can be interpreted by just about anything, any process that we have. But even if you have native, so if you are running like solid part, IPT files, PRT files that are coming native out of your platforms, you could upload those directly. We also take STLs if you just are looking for a 3D printed part, although you can actually 3D print from any solid model as well. DXFs, we actually have an auto extruder in our system. So if you're looking for like a sheet metal cutting pattern, you can actually upload your DXF and then extrude it to your thickness right in our website. So there's a lot of options. And then once you're on the site there, so I'm going to actually grab from our recent uploads. We're talking sheet metal, so let me just put a sheet metal case in here.
Perfect.
And I'm going to run through the defaults just to kind of show you what this experience may be here. But we are quick. I usually don't finish a sentence before our parts are priced. And when I talk about instant pricing, this is actionable, instantaneous pricing that you see on Xometry's site. So in this case, it's going to interpret that 3D model and it's going to price out in the lowest cost option based off all our processes. And that's at quantity one lowest cost. So in this case, it's actually defaulting to an SLS laser sintered nylon, which is a very good generalist material for 3D printing. But we do know this is a sheet metal part, so I'll go and configure that in just a second here. But you can already see that you have your price. You could actually see when your delivery date would be. You could even get save some money if you have more time on your part, or spend a little bit more to get it quicker. If you are working something more specified, like I said, when I design parts, I'm designing parts on purpose. They may actually have specs and certifications against them. So if you need a certs, like say, for example, I'm export restricted on this, I'm using the aerospace and defense part, I'm a checkbox away from ITAR restriction. So just click that and it automatically sets a workflow for that part that will always be ITAR export controlled. If you need COCs, traceability, and material certs, again, all these options are checkbox away. But,
and to be clear, Greg, the numbers you see at the top, the expedite versus standard versus economy, those aren't shipping dates. Those are the actual manufacturing, right? So it's not like doing ground shipping versus air shipping. We're talking about putting it in the queue at the manufacturer. If you put it in the queue as I need it right away, it costs more because they have to reprioritize what they have on their plate.
Correct. So like this is the all-in bundle here. So expedite's considering 1 day delivery, and that's that's if I press go right now, my expedite, I will get at my dock or at my door October 21st. And keep in mind we're at the end of a week, so there's 2 days in that weekend right now that are incorporated within that. So it's usually this is within a week, so within a couple a couple business days in reality. But let's go ahead. All right. So so this is my prototype. And I'm going to briefly go through this because I know we also are going to be showing a little bit more of the site with you, Jason. But I could go review my part, look at some information on it. Let's say I actually need to make 5 of these parts, and you know what? They are actually sheet metal. So just as quickly as I could get a quote for 3D printing, and you can see some of our 7 3D printing processes here, I could go and get quotes for more traditional processes like machining, metal, urethane casting. And let's go ahead and make this sheet metal. And I'm going to choose 5052 aluminum, which is just a very standard aluminum. And you can see my pricing and lead time updated automatically. Let's go a little bit further and just make this a more spec part. So let's say I actually have 4 PEM inserts in this and 4 welds to weld up these seams here. This is stuff that people don't usually consider as an auto quote option. And boom, 4 inserts, 4 welds, price, lead times, updates. I could even go even further. Let's go ahead and give it a powder coat. And heck, I need to also, I also want to put my logo on it with a silk screen. It's all that stuff just updates automatically on our site. And again, this is just an actionable, purchasable price. No more please quote quantity 5, 25, 50, 100. If I need 37, I type in 37 and my pricing updates automatically. So that's kind of the power of this is you go from one-off prototype to moving into spec manufacturing and beyond. And it's all within one site. It's also something that you can go to for multiple processes and just check out like any other e-commerce site once you're ready. So Jason, I'm going to hand the mic back to you from that because I want to kind of stir the waters and get people idea of how our site works and how it's good for any aspect of the product development process. But I really want to see you develop a product.
That sounds like a plan. All right, cool. So we have a project already picked out for today, and that project is going to be this. Oh, you can't see it. Hold on a second. That's the problem with virtual backgrounds. This air quality sensor. Now, this air quality sensor works by sensing the quality of the air around us, and it shows you that quality via lights, via the LEDs at the bottom. I thought this would be an especially useful product today based on all the wildfires that we've had in recent days. That air quality on the West Coast has gotten pretty bad. This would be a great way to be able to check what that air quality is without even having to go to weather.com or one of those other sites. So this product is a consumer product that involves electrical design or PCB design, as well as a mechanical enclosure. Most consumer products with electronics are going to involve the E-CAD and the M-CAD side of things. So I thought this would be a great project to showcase in Fusion 360 because although most people would think that Fusion 360 is a mechanical design tool only, in reality it can do both the electrical and the mechanical side together. And that seamless integration allows you to be able to collaborate between an electrical engineer and a mechanical engineer. Or if you wear multiple hats in your organization, you could do both the electrical side or the mechanical side. Anyway, enough talk. Let's jump right into the project. I'm going to share my screen here. And, oh, we're not ready for Q&A just yet. Let's jump right into Fusion 360. Here we are. So this is the 3D model that I have currently for this particular design. And I'll tell you that based on my project needs, I actually outsourced both the mechanical design, or at least the initial mechanical design, and the initial electrical design. Right now we're looking at the mechanical enclosure. It has quite a few different components. We have a shell that's the top of our product. And then inside you could see I have quite a few different pieced components or off-the-shelf components. I have an injection molded housing for this Honeywell PM 2.5 sensor. I have a battery up top. I have a spacer down below to give me room for the PCB that you don't yet see. I have some hardware, which I pulled in from McMaster-Carr right here under Insert McMaster-Carr Component, which directly ties to the McMaster-Carr website. I have a diffusion ring for the light so that it diffuses and looks very nice. And then I have our base at the very bottom. There are two components we're going to focus on today besides the PCB. We're going to focus on the base here at the bottom, and we're going to focus on the shell. That's the outer enclosure here. But mostly I think we're going to end up focusing on the base. And let's jump in and bring our PCB in. So again, I outsourced the PCB design. I hired someone who's using Autodesk Eagle, and he designed the entire PCB for me, but he didn't know exactly the shape and size of the enclosure. So he made the board a little bit too big on purpose, knowing that I could just go and change it later. And that's what we're going to do here in just a second. But before I do that, I think I should really inspect things to make sure everything is going to look good. And I'm actually seeing a problem. Let me ask you this, Greg, do you recognize this component right here?
So that looks like what I usually would use as a data connector.
Exactly. And I could tell you right now, this data connector is supposed to be on the bottom of this board. And not only that, it's supposed to line up with this rectangular cutout on the bottom of the base so that I can actually plug something in. Now, you worked in the industry, so what would you do about this? How would you go about fixing that?
So in my past, what would happen, because I was the middleman, so I used to work kind of on more of the systems engineering side of things, where the E would give me a step file of the PCB design, and then I would get that step file prepped to give to our ME, who would then integrate it in. And it would be a back and forth because now the ME would come back. We'd go talk to the E. He'd have to go redesign the board, reconfigure that based off what he heard, right, and the specs, and then again send it back to me. I'd retransfer to a step so we could go and give it back to the ME. So it was pretty cumbersome.
And let me guess, you probably took screenshots, put them in a program like Microsoft Paint, and then try to scribble scrabble what you wanted?
You know, I'm advanced. I use Snagit. I mean,
all right, fair enough. Fair enough. Well, I'll tell you, the beauty behind Fusion 360 having E-CAD and M-CAD all in one place is that I could actually change it right here, right now. Now on the screen at the moment, right now we're looking at the assembly file, but I also have my electrical PCB project file. I have my schematic open as well, and then I do have a 2D board layout. Now, when you would tell the electrical engineer, hey, can you please move this to the other side of the board? Can you move it in this position? This is typically where they would change things. And you can certainly make that change right here, but you'll notice that I can't see the enclosure right now. I can't see how to line up this header right here with where I want it to be. So the cool thing about Fusion is that the mechanical and the electrical side of things kind of work together. And so in this particular case, let's jump right back to that assembly. We can go and edit the PCB itself within the context of the assembly. And I have tools that are PCB specific that allow me to be able to make these changes. So for example, I have this flip 3D PCB component, and I could flip this to the opposite side of the board. That was pretty easy. Now I could go and take this and use the move tool to go and move it. And because I can see the enclosure, this makes my job really easy to be able to line things up. So let's go and do that. Let's actually go and line this up. Sorry, it's the wrong window there. I'm gonna go and grab this guy and just line it up exactly where I want it to be and hit the OK button. That easy. Pretty cool? Greg, that's you. You're supposed to say, yes, Jason. Very, very cool.
I am in awe and
Okay,
speechless.
good. No, let's take it a little further. Now, I created some problems by doing that because I have an integrated circuit that was where I just put that header. So I'm going to go and move that as well. We're going to go and rotate this 90 degrees. Now, one thing to note is that this particular board does not have all the traces already filled in, so to speak. And I did that on purpose. My personal recommendation is to figure out where these components need to be with respect to each other and with respect to the rest of the components in the assembly. And then once you're able to lock down those positions, then you could go and do your traces rather than having to go and rip them up and recreate them. So this is just a really quick way to be able to do that. Now there's one other problem with this particular PCB. Greg, can you point out anything in particular? See this
Yeah, I mean,
enclosure around it?
as much as I like the green FR7 board, I probably don't want this enclosure sticking out.
I wouldn't either. So we're going to go and edit the profile for that particular board. You'll notice that I can still see all of the other components that are in here. So I could do things like project, for example, the inner edge of the enclosure itself. And now we can actually use that to guide the size of the PCB. So let's go and hide the shell itself. The magenta circle that you see here, that's the actual enclosure, like that inner edge. Now I could go and take this outer PCB outline and set an offset. In this case, let's say 1 millimeter apart. I'll make sure that these are also concentric so that this is actually gonna be perfectly aligned with each other. And we'll go with, I think 1.5 millimeters should suffice. I hit the finish button, and in just a couple of seconds, my board is gonna update with one exception. You will notice that the screen here, the silk screen, isn't updated yet. And the reason behind that is because the origin of a PCB is typically the bottom left corner of the board. And if you change the size of the board, that origin moves. The screen is related to the origin, so of course everything is a little jumbled, at least temporarily. The key though is that I made the changes to the board. Now I could go and push those changes to the 2D board layout. And when I recreate that board, it's gonna update everything for me automatically. Pretty cool stuff. Greg, any comments about this based on your experience in industry and what you're seeing here today?
It's I really like that you're integrating electromechanical, truly, right? You're actually putting this all in one assembly setting and being able to live manipulate. It's something I haven't seen before, and it's something that I think is just what's needed to be done because most components now have some sort of electronics aspect to it. It's no longer discrete mechanical goods, it's always electromechanical systems.
Exactly. Well, let's focus for a little bit on the mechanical systems. We'll come back to the PCB in just a little bit. I said that we're going to work on 2 components, but I think we should focus on the base for just a couple of minutes. So I'm going to go and isolate this base and actually re-isolate it. There it is. And we want to see if this is going to work. Now, I could go and truly analyze this, until I fall asleep, basically. But I want to hold this in my hands. That's like the best way to really see if this is going to work. So we're going to go and use Zometry to prototype this. Although I have access to a 3D printer, it right now might be building something else. right? Or if I work at an OEM and I have 5 3D printers, they might just have me in the queue for tomorrow or the day after, and I really need this part right away. So we want to 3D print this via Xometry as quickly as we can. So I'm going to take this part. We're going to jump right over to Xometry. Let's go and find your website here. I'm going to go and sign in. One thing you'll notice when you go to sign in is that there are actually 2 different sign-in options. There's a customer sign-in. That's the one we're going to use today. I'm going to be a Xometry customer. But there's also a partner sign-in, and that's something that the vendors or the CNC machine shops or the 3D printing service bureaus would use to go and accept your parts and print it on behalf of Xometry. More on that to come in a couple of weeks. We're going to have another webinar. That one's going to be between Greg as well as one of my colleagues, Phil Brown. But for now, we're going to use that customer sign-in. Let's go and sign in. I'm really hoping I remember my password, so we'll see that in a second. Thankfully, I use one of those password services, so that should already be good to go. And then we're going to go and choose to either upload a new file from scratch, or if we want to save some time based on upload speeds, I'm going to go and use one of my recent uploads. In this case, we're going to look at the base part in particular, and the V27 is the one that I think we want. So we're going to go and grab that one. Next, we're going to go and choose what kind of process we're going to use. Now, this one is meant to be, for at least for me right now, quick and dirty. I just want to hold this part in my hands. So I don't really care about surface finish very much. I do want it to be accurate, of course, but the resolution doesn't have to be crazy. So I'm thinking FDM or maybe SLS. Greg, do you have an opinion on that?
So I call SLS kind of like the 80% tool, because 80% of the time in a prototype you need it, it's gonna fit the bill. Like SLS just makes parts in. I actually have a nice little SLS piece here. It can make parts of various geometries. It's very, very forgiving because it doesn't require support structure. So whether it's an organic shape or something more mechanical in design, you can use it. It tends to be relatively inexpensive for industrial additive manufacturing. Something to note is that Zometry, everything that we offer is that industrial 3D printing. So we have this super high throughput machines, many different materials, and a high level of reliability for our service versus versus desktop printers, and it usually gives you much more robust options.
Yeah, and it looks like, I was comparing the FDM process to SLS here, and most of the FDM processes for this particular part are around $45. The SLS is about the same price as well. And so if I'm going to get to choose between the two, I'm definitely going to pick SLS as well. And then I don't need any other special things here, so I could go and save this, put in my credit card information, and a couple of days later, a part's going to show up. But in this particular case, we're on a live webinar and we don't want you to wait that long. So here is our part. Let's go and turn my camera just a little bit. And I'm holding this part in my hands. And the cool thing about it is I could feel that sugar cube texture that you've talked about, Greg. But this part looks really, really good. Looks as I intended it to be. And then I could go and put this in my actual assembly and see if this is going to work or if I need to tweak things. So exactly what a prototype is meant to do. And of course, I also have my calipers handy pretty much at all times. And I could go and measure everything and really just check things. Because when you're looking at a 3D model, it's easy to measure things, of course, and it's easy to at least conceptualize what it's going to do. But when you hold it in your hands, you learn a lot that you would never get from that 3D model.
Yeah, and something that's kind of unique about the SLS is printing in a thermoplastic, right? It's printing in nylon. Something I've been accustomed to doing when I'm doing a prototype process, especially if I know that I'm tweaking my design in CAD, is I may actually take that design in SLS, print it out, and if I'm finding interference or fits, this nylon is enough that you can drill into it, you can hack it, you can modify into this part, and you could take some of that stuff that you do in your physical manipulation and then reflect in your CAD, so offsets and holes and other features. So I like it as a prototyping tool, because unlike some other materials where they may be more brittle to use, SLS is pretty durable even from a hacker standpoint. You could actually really modify the part to fit your needs in a prototype situation.
I agree 100%. Now, we already have the part. I checked it and it's mostly good. I wanted to tweak a couple of little things before I go and make the final part. But one of the things I forgot to mention is that even though I 3D printed this one just as a quick gut check, my end goal for this part is actually to CNC machine it. So you mentioned earlier that you have those design guides for all the different processes, and I just didn't happen to read the one on CNC machining yet. So Greg, can you tell us, just from looking at this part, what problems may I run into? What changes should I make to this design before I go
Yeah.
and I make that CNC part?
Yeah, and I think it's really good to differentiate too. Like when I talk about problems that are designed for manufacturability feedback, my goal is really to save costs, for you. So when we say problems, it doesn't mean that we can't make this design as is, but you may have design features that are actually driving costs more than you think. Like could actually like add like $100 to this part. Because you're increasing machine time on this. So usually I'm going to start looking at the biggest things, which are going to be drill depth ratios to radii. So when I look at the pockets of the parts, that internal rectangular pocket, I'm probably going to be looking for at least like a 32nd of an inch radii on that, because that's standard for a small tool that would be used to cut this. And when I'm CNC machining, of course, I'm using a cylindrical end mill tool to drive down into the part and then move across that part, removing material. So all those internal corners do have to have a round to them. When you have a sharp internal corner, that's something that you need another process like EDM to create, and that can add significant expense to your part. So always make sure you have rounded internal corners if you're doing CNC machining.
Cool. I'm going to
Now,
pause you for a second, Greg. Now, one of the things I was just showing in the background is I could use the measure tool, also called the inspect tool, to go and measure my fillets. That's pretty easy. But there is a new feature, it's somewhat new, that I love, and that is under inspect, you're going to see that we do have a minimum radius analysis tool. So I highly recommend you look at this, especially for CNC machine parts. I'm going to go and turn on the one that I already have set up here. And what it's showing is all your radii in green that you're good to go, and the red are going to be the ones that are too small. If I go and I edit this particular analysis, you'll see here you can set the maximum tool radius as well as the minimum, and anything that's smaller than that minimum that you set will show in red. The really cool thing though is that you could leave this on as you're designing and then tweak this, and as you tweak it, it's going to give you the different color map telling you that you fixed the design. So in this case, I'm going to go and make the quick change to that radius over here that you mentioned. Right now it is 21 thou. And what was the minimum that you said?
So about a 32nd of an inch is going
All
to be a
right.
minimum radii.
So let's go and do this. And I want to do all four at the same time. So I'll go and select those. Cool. And we're going to go with 1/32 and inch. Let's go and do that. Excellent. Give that a second. It's going to recalculate. Oh, I think I might have botched that up. Let's try that again. I'll just go and do this manually even. Make this just a little bit bigger for us. And there we go. Now, actually, I think what I did wrong is I think I set the minimum tool radius here that's wrong. That's really the problem. There we go.
Now,
And
all
now
green.
everything is correct. All green is good. What else do I need to change before I go and I CNC machine this?
So again, the other cost driver that I see here is you actually have on those three bosses, they're not quite bosses, they're kind of open on one side. And when I'm milling that, I'm actually, it's not just a drill, right? So now I'm actually pocketing. I'm creating, I need to take a really long, thin aspect ratio end mill and cut in that kind of U-shaped pocket there. And that's going to add time to making this part. And so again, at quantity one and prototyping, all right, that's good. It's going to be a more expensive CNC part. But if you're like, hey, it's time to make 600 or time to make 6,000, I may raise my hand and say, listen, if you don't need this U-shape and you can make it a boss, so like a drill through hole, it's going to save a lot of time. And when you're talking about making parts into production, time on the machine is going to be driving that cost. So like it's going to reduce machine time. It's going to reduce the cost of that part. So yeah, if you could turn that into a full boss, I think it'd be great.
Cool. Now keep in mind, Fusion 360 is a parametric design software. So at the very bottom of my screen here, this is what we call the timeline, and it's a recipe for creating this file from scratch, left to right. Now, I said at the very beginning that I hired consultants to do most of the work for me, and my job is really just to make sure it all fits together. The consultant I hired to do the initial mechanical design wasn't even using Fusion 360, so the file that he gave me happened to have been a dumb generic CAD file, like a step or an IGES file. Now, with most of the parametric modeling softwares that are out there, if I want to go and make changes to that model, I might even have to recreate parts or even the whole model to be able to make those changes easily. But Fusion 360 has a technology built in called direct editing, also sometimes called direct modeling, and it allows me to be able to manipulate this model very easily without actually having to redraw anything. So Greg, you said that I should change these bosses, and I think I know what you're talking about. So what I'm going to do is I'm going to select a couple of these faces, and I'm going to select this one and this one as well. And what I'm going to pick in this case is I'm going to hit the delete key on my keyboard, and I think that's what you're talking about doing. Is that right?
That's pretty amazing. Yeah. Yes, that's usually I would have thought you were gonna like extrude over top and you know, taking some lines, extrude through, but that's pretty amazing that you could just do that right there. And you do not have like you don't have the original, you know, history tree data of
Correct.
this file, so you could just do that directly with a step edit. That's pretty cool.
Now, the other thing I want to do, and this one isn't exactly designed for manufacturing, but more based on my own measurements and assembling my part, I want to make this hole just a little bit bigger. So I'm going to go and use another direct editing tool. I'm going to select these three holes here, and I can choose to change the radius on all of these. So we're going to go and make them just a little bit bigger. I really don't need a lot. So I'm going to add, let's say 0.1 millimeters. And I'm just going to make sure that this is the correct like minus or plus direction. So I think I want minus here, and that's looking good. But I have the feeling you're going to tell me that this wall is now just a little bit too thin.
Yeah, so if I'm working with a material like aluminum and I'm drilling that hole, you're probably going to see a bulge there because aluminum is going to be too soft to actually hold that shape. So you're going to want to thicken that wall just a little bit more.
All right, so let's do that too. Again, use direct editing because I don't have the true history of this part. I'm going to go and grab these, and let's go and add 0.3 millimeters, I think. That's pretty close. I think I have room for enough to go with 0.5 millimeters. Yeah, that'll look really good. And I already know the assembly, so I know that I can accommodate that. Any other things I should look out for here?
I think that's, you know, I really think that's it. So we were talking about this a little bit earlier, like what would it take to make this part? So this would probably be made on like a 3-axis mill with, you know, 2 reel setups. So like, you know, doing a one side flipping, using a soft draw to hold them, and then doing the secondary operations of this part. So overall, I mean, it's the cost of this is now just the operations of this, are those 2 operations and removing of that material around this boss feature. So I think you're pretty solid.
That makes sense, but you did bring up one other thing that I think was important, which is the 2 setups, right? I'm gonna have to be able to machine this from above, and then I'm gonna flip it and machine it from below. So I need to make sure that my geometry is actually accessible from both
Oh
sides. Is
yeah.
that right? All right,
Yeah,
good.
so undercuts would have to require another operation, or it may even be, you know, something that you can't manufacture.
So under the inspect drop-down menu here, you're going to also see accessibility analysis, and that's exactly what this is intended to do. You choose your particular object, in this case, this body, you choose the direction, and it's going to highlight in green and red what's accessible from above and what's accessible from below. And what you're really looking out for are going to be pools of green inside the red areas or pools of red inside the green areas. And in this case, everything is looking really good. So I don't have any undercuts. So I think this is ready to manufacture, isn't it?
Ship it.
Cool, let's do it.
Full send. Yeah.
Okay, so we're gonna save this part out. And in this case, I'll save it as a step file. I'll jump back over to Zometry, and we're gonna go and delete this particular part. We're gonna go and bring in the new one. So we're gonna start from scratch in our dashboard. I'm gonna again use my recent uploads to save us a little bit of time. Now I'm gonna grab the latest version, which is version 28. And I'm gonna go and take a look at the pricing, and we'll look at all those options before we actually go and pull the trigger. So I see all of my options here. I actually want to CNC machine this. So I'm going to go and get my instant quote, give it a couple of seconds to do all of its math. And if I remember right, you were saying that you're actually using machine learning based on all of the parts you've ever machined to be able to figure out the pricing. Is that right?
Yeah, so this is actually kind of the secret sauce. Like, how can you quote this quickly if you haven't figured out the tool paths, right? How do you get this pricing? So our goal is to build what's called market fair pricing with with over 4,000 manufacturing partners. We're constantly sending work out, and we have information about those geometries, about the parts, about the materials, the features, the finishes of those parts, and we could actually create a prediction of a part, this material at this shape, at this quantity, on an open marketplace with a competitive manufacturer would cost this much. And it allows us to have competitive pricing for manufacturing across multiple geometries, multiple materials, multiple processes. So all this is actually machine learned and AI trained, and it's a constant feedback loop because we're constantly making more parts, and that accuracy is getting more, or we're getting more and more accurate as time goes on.
That's awesome. Now I see that this particular part is going to cost me around $500 for standard delivery. That's it's a reasonable price, Greg, but I'm not there yet. I'm not sure that this is truly going to work. So what I might want to do, that I'd recommend to at least consider, is I could actually go and modify this part and say, you know what if I'm not ready to CNC machine this yet? What if I want to do another round of 3D printing? This time, instead of using the SLS, maybe I want to go and use SLA, or maybe I want to use another process. I could go and choose one of these materials, a color if I want, and now the price is only $70. That actually feels really good to me. So I'm going to send this off, wait a couple of days, and lo and behold, the magic of the internet.
You're opening the oven and the chicken's already done there. It's great.
Yes, it is. And this part is, I mean, it's nearly identical to the original, except for the changes we just made. And now it's printed in SLA, and I could tell you the surface finish on this is magical. I love this.
So yeah, the power of SLA, and first off, we actually have, SLA is a UV cured photopolymer. So it actually starts as a liquid resin and gets cured by a laser, but that liquid surface finish kind of takes the shape of the part there, and you end up getting a smoother finish than that SLS nylon, which is from a powder bed. So you have more of a kind of a powdery feel on the texture. But we actually have over 15 different SLA materials available through Zometry for a variety of prototyping. I highly recommend SLA when you're looking for concept models, things that may actually be whether it's like you're sending to your CEO for marketing approval, or if you're actually doing a final fit check. SLA is one of the most true to CAD 3D printing processes out there. So if you're about to invest a lot of money in an injection mold tooling, it could be worth doing an SLA prototype or two to verify. Also, SLA is one of the few 3D printing processes that can print in translucent materials, and we have one of our materials, Accurate Clear View. We actually have a quick clear finish, which is essentially a clear coat, a glossy clear coat on top. And so, in about the same time that you're going to get your 3D print, you could actually get a nice clear print as well if you're looking to make a window or a light pipe or something like that. This is just an SLA
awesome.
Clear View part.
That's cool. So I have the part, I have the original and of course the newer one. The newer one is looking really good. Now I feel a lot more comfortable spending the $500 something on the CNC part. So I'm gonna send this out to Zometry again. I'm gonna get my metal part. I'm looking forward to it, but I don't have to wait very long, do I?
Open the oven, man.
Here we go. So this is going to be the same part again, this time made in aluminum. The 7075 is what I believe I picked. And this is going to be the exact part. Sorry, the virtual background messes up the camera stuff here. So now you could see the actual part. The surface finish is fantastic. And I'll tell you, the weight of this is the real difference, right? The weight, and also, the cool to the touch metal. And the reason that this is going to be important to me is because for this particular electronics product, I wanted the base to be nice and heavy. I didn't want my product to fall over, so I wanted it to be like a nice low center of gravity, but I also wanted this high-end finish for this particular part. And this is exactly the high-end finish. Sorry, this is exactly the high-end finish that I was hoping for. This is perfect.
Yeah, I mean, I think that part, I mean, it just looks awesome. You know, you're also, you know, I love the tool pathing on that. You could also get multiple finishes on CNC machine because, like I said, we do spec manufacturing all the time. So if you do have an anodized, like a Type 2 or Type 2 color anodized, Type 3 hard coat, chem conversion coating, I keep on saying it's a drop down away. And it instantly quotes on our website. And also, I was just pointing out with that, yeah, you're going to be able to see how that price amortizes on our website as you add quantity, because a lot of that upfront price, that $500, is all that work that's needed to make the first one. Like you still have to do all the work to make it, like make those setups and program that. But then as you add quantity, you'll see that it'll start to amortize through, and on the per piece basis, it's going to get cheaper and cheaper and cheaper. And you may actually end up seeing, and actually we could actually go and as you add that, we could actually go and manually review if it's like raising a little flag, you're like, you know, I think it could be cheaper. We could go and look and see if we could add efficiencies in the manufacturing process. Because it turns out Zometry, we're also humans, and we have expert cost estimators and machinists on staff. You know, a lot of our machinists are, you know, 30+ year experienced. So we're able to review these parts when you're looking at production scales. Other thing I'd recommend is we also added on our digital Rfq Marketplace, which is a different aspect of Xometry where you connect directly with your manufacturer. We have die casting, and for a part like that, probably if you're doing an initial sampling, a market test, CNC machine is going to be the quickest, fastest way to go to get like exactly what you're looking for, because you need a heavy metal base. But we could also help guide you in the direction of die casting if you're like, this thing kicked off, I need to make thousands of them. There's always different scales of manufacturing available, and again, one of the things you want to be is that one-stop shop. You know, so whether you're prototyping SLS, you're moving into that initial market testing, and then you're building into full spec production, we're able to handle that type of work.
That makes sense. Now, we prototyped our base and everything is looking really good. We only have one more thing we need to do on our project. And so let's jump right back into that for a moment before we end up taking our Q&A. As a reminder, if you have any questions, please put them in the Q&A section. We would love to answer them in just a couple of minutes. This is the PCB that we designed before, and if you recall, after we moved some things around and changed the size of the board, the silk screen wasn't exactly correct. I did promise that we would fix that. It's as easy as saying, I have a 3D model, I want to push this to the 2D board layout. In just a couple of seconds, the 2D board layout is going to update. Here you could see it's looking good. All of those white lines connecting the components, those are air wires. We still need to trace all of the copper, and I haven't done that yet, but it's as easy as going a quick route and using potentially the auto router. And I say potentially because in my experience, I've seen that some people love auto routers and some people absolutely hate them and refuse to use them. But in this particular case, I'm just trying to get a board into my hands as quickly as possible. Just like I wanted to take the 3D model of the base and be able to hold that in my hands, I want to be able to hold this board in my hands. I want to be able to check the fit, and I also want to make sure it actually works. So let's go and trace this. You can see the auto router is just about done. It gives me different options here based on the number of vias. Generally speaking, the more vias you have, the more expensive your cost. So we're going to go and look at this last option with only 16 vias. This looks pretty good. I'm happy with that. So I'll end the job. And then now we're going to just go and push this to 3D one last time. That's where this is going to get cleaned up. It's taking all of the components that are on the electrical side of things. It's finding a 3D model for each of those and then assembling that into an assembly that has everything in the right place, exactly where it should be. But it's also showing you the copper. Now, I've seen examples of this in years past where we do exactly this, but the copper is really just a picture. Looks nice, it renders nice, but that's all it is. And I'll tell you, in this particular case, with Eagle being integrated directly into Fusion 360, what you have here is actual physical copper. Why is that important? Well, Fusion 360 is about CAD, CAE or analysis, and then CAM, which is computer-aided manufacturing. If you happen to have your own 3D printer or happen to have your own CNC machine at home or your own laser, plasma cutter, or water jet, you can control all of those machines and more via Fusion 360. And so I know, for example, there's a small CNC machine made by Shapeoko that's meant for prototyping PCBs, and I can actually control the Shapeoko CNC machine by using toolpaths generated from these copper traces right here. So it's pretty wild what you do here, all because Fusion 360 has integrated E-CAD and M-CAD. And Greg, you said in years past, you haven't seen anything like this. Where do you think this is headed in the future?
Well, it's interesting. So just I mean, I'm dating myself. There's a lot of people older than me, but my first CAD was my first CAD that did a 3D thing was Autodesk Mechanical Desktop.
Wow,
And I was,
you really just dated yourself.
yeah, and that was that was around 2000 or so, and at that point you're still in the AutoCAD mindset of I have to make my lines extremely constrained because it's hard to go back. And then Inventor came out, the first generation of Inventor came out, and you're like, oh, just make a box and then constrain it later, and we'll figure out the measurements from there. And you're now seeing this live manipulation like you're showing there, and you're seeing this integration of electronics. And I think like the future is going to be CAD, and I've seen this already with 360 and some generative stuff, is instead of telling the CAD to do the work, saying, hey, here's these things, here's what their tolerances are going to be, or here's going to be the stresses and forces. Make the shell, go and make the fixture. And like that's what you're really starting to see is this evolution of adding constraints and rules and having CAD generate more of that. So it's really great to see how all the systems blend together. And I think we're talking about a follow-on in a few weeks here with Phil about where the rubber meets the road. We still need to make these physical parts, and kind of showing how Fusion 360 can work there as well.
Exactly. I'll give a little plug to it right now, and then we're going to switch to Q&A. But this particular part, again, I'm going to cover the part so it doesn't go disappeared on us. But this particular part is going to get walked through by Phil to show you how you could go and machine that and cut some chips. And that'll be in about a week or two. The exact date is being finalized, but look out for that. You'll get an invite. And I guess that means that it's time for Q&A. So let's go and turn on that screen one more time. Q&A time. I'll go and grab our Q&A panel here.
Yeah, and I was going to say, there's a question and answer tab in Zoom, so please feel free to ask some questions. And I did see, by the way, I love I think this is what we were talking about, the AI-driven pricing, terrifying and awesome at the same time from Michael. It is kind of wild. It is kind of wild to see something that used to be so tough, like to get pricing just show up instantaneously. And we've even had manufacturers on our network that are like, no way. And then they put a part that they just quoted up on our website. They're like, oh wow, that's actually like almost identical to what we just quoted that part for. And seeing like this power of machine learning AI, and how it works. And the type of customers that we tend to attract tend to have more axes than 3. They tend to have more finishes than as cut, because this ability to just fully specify your manufacturing need. Because again, we're always making parts on purpose. It's not just like accidentally, oh, I got a metal piece. It's something that's designed with intent.
So Greg, I have a couple of questions that I see here that are more geared towards you. Would you mind if I read them to you?
Yes, sir.
All right, cool. So the first question is, do the quoted prices on Zometry include tariffs for offshore sources?
For the economy option on Zometry's website, so like I said, we have Expedite, Standard, and Economy. Expedite and Standard are both domestic options for Zometry.com. Economy is going to be an international option, and that's baked in. In fact, actually, I think this week we released free shipping on Economy CNC and sheet metal orders, so it makes it even easier. You see your price, and that's what you're paying. So you see your price and your lead time, and you know what you're going to pay there. And that's on top of free shipping for all our domestic 3D printing already. So when you see upload SLS as a small part and it's like $12, you're just gonna pay $12 and get those parts.
Nice.
But that is inclusive as far as the economy to from Zometry to you for CNC and sheet. That's all baked in.
Perfect. We have another question for you. This one's from Lonnie Rush. Lonnie wants to know if Zometry can also print metals.
Lonnie, I've been holding my DMLS piece in my hand as I've been doing the presentation because I always, if you guys have ever seen my presentations before, I always have stuff, just 3D printed stuff around me. But yes, we do direct metal laser sintering 3D printing as well as binder jet metal 3D printing. So we have two types of metal 3D printing platforms. DMLS is printing usually in steels and aluminum alloy. And it has a platform about 9 inches or so. And that's one of those direct processes. So you're directly 3D printing a part in like a fully dense alloy. And this is actually, I think it's stainless steel here. But you can kind of see that texture is, it's not, it's not polished. It's more like a, better than cast on the texture of that 3D printed part. And binder jet metal has a secondary process to it, or has a post-thermal cure to it, and that's something that's available on our digital Rfq Marketplace.
Very cool. It turns out, Greg, that you're getting all the attention today. There is another question geared towards you in particular, so I'll ask it. David Schroeder would like to know, he said, well, first of all, he says he loves the features to create and prototype single parts. For that, awesome, thank you. He says that since you've talked a little bit about what happens when you scale up to full production, does Xometry and the RFQ system work for finding assembling facilities or total manufacturing facilities?
Yeah, we would love to be part of that discovery for sure. So I'll give you, a couple examples of when we do light batch mechanical assembly. BMW, one of Zometry's investors, but they've been a customer beforehand. We do a lot of jigs and fixtures for the Spartanburg, North Carolina plant for the assembly of vehicles. So they like that because it actually is mixed media. It's usually like a urethane cast part for soft touch with a FDM part for the main body, with CNC Delrin for the rigid fixture pieces. And we're helping them put that together. So that's something that we can manually put together on the quote side, as well as things like assemblies and weldments on the sheet metal side, where it's not just making the parts, but it's also, putting them together to their specification. Usually after you weld them, there's probably a secondary aspect like powder coat for that. One other example, Jason, it's very relevant right now. We're probably all casting right now at our individual homes. We've been in lockdown. We actually have we released a case study on this of us working with a company called ClearMask, which is a Baltimore-based company that invented a transparent face mask. This is different because it's not just discrete manufacturing. When you're talking about masks, you're making these in the millions, so it's actually contract manufacturing. And as all of these supply chains were disrupted, Zometry really had this dynamic self-healing supply chain because we have so many manufacturers scattered all around that if one whole state goes down, we still have plenty up to take on the job. And we were able to help secure the manufacturing of these mask products, which are a variety of different processes to make and assemble. And they're getting a full turnkey solution through us. So we've definitely stepped up to the plate on larger scale production, and it's kind of been accelerated because of the situations that we've been in.
That makes sense. Well, I suppose that concludes our Q&A. We have just a couple more things to cover before we wrap up. The first thing I want to do is just thank Greg for coming out today and joining me for this particular webinar. Greg did a fantastic job, by the way. I hope you guys all agree. But just remember that Xometry is able to fulfill all of your prototyping and also production needs. And if you would like to reach out to Xometry, of course, you could just go to the website and reach out through the normal channels, but you are privileged. You joined our webinar today, and so you can also reach out to Greg directly. In the bottom right-hand corner here, I've included Greg's email address, his phone number, everything besides his physical address of where he lives. You can reach him via all of these different methods if you would like to. And remember that he works with customers on special projects. So if you have a special project you'd like to work on with Greg, please reach out to him. And then lastly, I'm going to plug my team. I work on the Autodesk Fusion 360 team, of course. And if you are interested in Fusion 360 to help your business be able to achieve your dreams quicker, faster, and more affordably, we are here to help. You can reach my team via Fusion 360 demo at autodesk.com. And also keep in mind that Fusion 360 is currently running a promotion of 40% off. That promotion ends at the end of day tomorrow. So if you are interested in Fusion 360, I highly encourage you to reach out to me and my team as soon as possible, and we can help you get all your questions answered. And if you need some more specific training or more specific kind of questions answered about your workflow, that is the best way to get them answered. So please reach out to us for all of those things as well. And so I suppose from my side, I'll just say thank you all for attending today. I hope you enjoyed it as much as I did. Greg, any last final words from you?
Just keep communication open. And honestly, Jason, I learned a lot today from our last conversations about Fusion 360. So I think this is just a really great pair from the design stage all the way to reality. So just really happy and pleased to be here. Thank you so much.
Cool.
And thank you all.
Thank you, everyone, and I hope you have a great day. Don't forget that with Fusion 360, you can make anything. Have a good one, guys.